Just let me know.
In early 1972, a probe known as Pioneer 10 was launched into space on a mission to the largest planet in the solar system. After millennia of speculation and wonder, humanity got its first close-up view of Jupiter. Accelerated by the immense gravity of the planet, Pioneer 10 was then catapulted into deep space, destined to leave the solar system and roam the galaxy for billions of years. On the off chance that this vestige of humanity should one day be intercepted by an alien intelligence, it was affixed with a message. A message designed to answer three central questions.
Where we are, when we are, and who we are.
More than half a century has now passed since the launch of our first galactic emissary, and in that time we've made numerous attempts to communicate with life beyond, either by attaching greeting cards to probes headed for interstellar space, or by targeting our cosmic neighbors with high-powered beams of light. So far, humanity's been left unread, but that could change at any moment. As long as we keep making noise, there's always a chance we'll be heard. An exceedingly slim chance, as we'll see, but a non-zero chance nonetheless. Given the paradigm-shifting potential of contacting beings from another world, it sure would be nice to know what exactly we've been telling them all these years. I mean, don't get me wrong, where we are, when we are, and who we are sounds really neat and all, but it's not exactly rich in detail. So let's start with that plaque on Pioneer 10. What does it say, and more importantly, to whom should I direct my anger when the aliens arrive to harvest my bones? The idea to attach a message to Pioneer 10 was the brainchild of journalist and author Eric Burgess. Less than 4 months before the probe was scheduled to launch, Burgess approached famed astronomer and science communicator Carl Sagan, who in turn relayed the proposal to NASA. Sagan was given 3 weeks to devise the message, and with the help of his wife and artist Linda, as well as fellow astronomer Frank Drake, they scrambled together a series of pictograms etched into a gold-laden plate of aluminum. In the words of Sagan, "It is written in the only language we share with recipients, science." Near the upper left corner, we find a diagram of hydrogen, the simplest and most abundant element in the universe. One electron bound to a proton. More specifically, the diagram depicts a single atom of hydrogen transitioning from one energy state to another, which is meant to be conveyed by this horizontal line here in the middle. This shift in energy is known as a hyperfine transition, and it's accompanied by the emission of a radio wave. That radio wave has a very specific frequency that's so prominent across the universe that we've given it a name, the hydrogen line, something that beings of sufficient intelligence to capture a drifting spacecraft would no doubt be aware of as well. In human terms, it has a frequency of about 1420 MHz, which means that each cycle of the wave has a period of about 0.7 nanoseconds and a corresponding length of roughly 21 centimeters. The recipients would obviously express their measurements using something other than nanoseconds and centimeters. But what's important here is that they're measuring the same thing and that thing never changes. The duration of one wave cycle and the distance covered during that cycle remains the same across the universe. This allows us to establish a shared unit of both time and length. We're basically telling the aliens to treat their measurement of the hyperfine transition of neutral hydrogen as one unit of time and one unit of length. That's why there's a vertical line here in the middle, which is meant to convey the concept of one in binary. But of course, hydrogen is merely one of many possible interpretations of this diagram. The aliens could just as easily think it's some sort of language, technology, star system, or literally anything else. To help them narrow down the list, the plaque includes 3 outlined silhouettes of a man, a woman, and Pioneer 10. These illustrations were drawn to scale so the aliens can use the spacecraft's diameter as a basis for deriving the height of the 2 figures in the foreground. In human terms, that would make the man approximately 182 centimeters and the woman about 169. The woman's height has been further emphasized by 2 demarcation marks along the right edge here. Between them is a sequence of 4 lines representing the number 8 in binary. The purpose of this number is to communicate to the aliens that the woman is 8 times as tall as the wavelength of the hydrogen line. In human terms, that's about 169, just like the woman's height relative to the probe's diameter. In other words, the interpretation of this as a schematic of hydrogen and the interpretation of this as an outline of the spacecraft are mutually corroborative. They provide the aliens with a means of deriving the height of this figure on the basis of 2 distinct measurements, which should help them narrow down the list of possible interpretations. At least, that was the idea. But when you actually measure the height of the couple relative to this sketch of the probe, you quickly realize they're about 10 centimeters too tall. While I have no way of confirming this, I suspect the source of this discrepancy is that the Reflect Edition Pioneer 10 is not the perfect circle. It's slightly wider in this dimension than in this one, known as a major and minor axis. If we assume that this outline of the probe is oriented with a minor axis along the vertical, the relative height of the couple is indeed what you'd expect. But if that is what the Sagan's and Drake intended, only 2 of the 3 antenna struts should be visible here in the front. The fact that all 3 have been drawn on the plaque implies the probe is oriented with a major axis along the vertical, thereby increasing the couple's height by roughly 10 centimeters. Nevertheless, it's hardly surprising for an oversight like this to go unnoticed, given they only had 3 weeks to assemble everything, and Sagan acknowledged they could have done a better job had they not been so pressed for time. Moving on to the left side of the plaque, we find a starburst pattern of 15 straight lines emanating from a central point. This is a galactic map of pulsars that's meant to help the aliens pinpoint the solar system. Pulsars are rapidly rotating neutron stars that can easily be spotted from thousands or even millions of light years away. They're often described as cosmic clocks or lighthouses because they're not only extremely bright, but pulsate at very consistent rates. This red line shooting off to the right represents the distance between the Sun and the center of the galaxy, while the green lines represent the relative distance between the Sun and 14 pulsars. To make it easier to identify the pulsars, each line is accompanied by the star's rotation period expressed in binary, marked here in blue. Take this one for instance. This star is known as the Vela pulsar, and it's about 1,000 light-years from Earth. Its rotation period has been expressed in wave periods of the hydrogen line and reads 126,726,823 when translated from binary to decimal. What that means is that it takes the Vela pulsar almost 127 million times longer to complete one rotation than the wave period of a hydrogen atom undergoing hyperfine transition. In human terms, that's about 89 million nanoseconds or 11 rotations every second, which is about this fast. By scouring the galaxy for pulsars that match the information embedded within this map, the aliens could, theoretically, triangulate the solar system. In fact, the chart not only discloses our location in space, but also in time. As Sagan put it,
where we are, when we are, and who we are.
This goes back to the cosmic clock analogy because pulsars gradually wind down at highly predictable rates. So even though the Vela pulsar will have a much slower rate of spin by the time it's observed by our hypothetical aliens, they could simply wind back the clock until its rotation period matched the one etched into the plaque. Repeating that process for at least some of the other pulsars would enable them to figure out not just from where, but also when Pioneer 10 was launched. At least, that was the idea. But when the plaque was created, the existence of pulsars had only been known for about 4 years. Astronomers have since learned a lot more about them, and they're not nearly as rare, stable, and long-lived as once believed. They can only be observed from very specific vantage points, and unpredictable speed-ups, slowdowns, and glitches challenge the cosmic clock analogy. Sagan and Drake were aware of at least some of these issues, but there was only so much they could have foreseen with the limited data available at the time. In fact, there was such great uncertainty regarding the distance of some of the featured pulsars that they added these breaks in the lines, indicating they're based on rough estimates rather than exact figures. Finally, on the bottom of the plaque, we find a plain schematic of the solar system. These binary numbers represent the orbital distance of each planet, expressed as multiples of 1/10 of the mean distance between the Sun and Mercury. For instance, the number above Earth reads 26 in decimal, which means it is 26 times further away than 10% of the distance between the Sun and Mercury. The obvious problem with this approach is that it requires the recipients to already be familiar with the solar system. Otherwise, 1/10 of the distance between the Sun and Mercury is completely meaningless. We might as well expect them to be familiar with kilometers or miles. To quote the creators of the plaque, "There is no way for this unit of length to be deciphered in the message." It's unclear why the Sagan's and Drake knowingly used an indecipherable unit of length when they had already gone through the trouble of creating a universal yardstick with the schematic of hydrogen. My best guess is that the wavelength of a state-shifting hydrogen atom was simply too small a unit to represent interplanetary distances, and the resulting binary strings became too long to neatly fit on the plaque. Again, they only had 3 weeks to do all of this. Last but not least, the trajectory of the spacecraft has been traced with an arrow, and the probe's main antenna is pointing it home. Over half a century later, Pioneer 10 is now more than 20 billion kilometers from the Sun. That might sound like a lot, especially given how I just emphasized that number, but it's only about 3 times further away than Pluto, and it takes less than a day for a light beam to cover the same distance. Even though it's darting through space at several kilometers per second, the probe won't surpass even the nearest star to the Sun for many tens of thousands of years. But it gets worse because Pioneer 10 is not headed for any particular star. It's expected to pass within a few trillion kilometers of a relatively nearby system in about 90,000 years or so, when this star, all the way out here, will come closer to the Sun than Proxima Centauri is today. While an exoplanet has yet to be detected around this star, if one does exist, and that planet just so happens to be inhabited by intelligent beings in possession of technology that allows them to detect a perfectly silent and practically invisible speck gently gliding by their system at a distance greater than 1,000 times the orbit of Pluto, then yeah, maybe they'll see it. A nearly identical probe was launched in 1973 known as Pioneer 11, and it was outfitted with the exact same plaque as Pioneer 10. Much like its predecessor, Pioneer 11 was just kind of hurtled into deep space with no particular target in mind. While a chance encounter with another planetary system is not impossible, even across timescales of many billions of years, Sagan and Drake believed it was more likely for the probes to be scooped up by an alien spaceship traveling between the stars. Some studies have shown that space is, in fact, a tiny bit big. It's very easy to criticize the Pioneer plaques. Any message designed to be understood by beings of which we know nothing about will unavoidably rely upon assumptions that could easily be false. Will the aliens understand the meaning of an arrow? Will they comprehend binary notation? Will they even grasp the concept of conveying information using two-dimensional pictograms? While questions like these are perfectly valid, they're ultimately quite pointless because the answer is always the same. We don't know. We don't know what the aliens look like, how they think, or even if they exist. The plaque could be so at odds with how they perceive and navigate the universe, they fail to even recognize it as a message. Or we might be foolish for thinking a civilization so technologically advanced they're able to locate and retrieve a derelict spacecraft from the dead of space will be stumped by an interstellar cave painting. While many believe the recipients will be nothing like us, we could just as easily have a lot in common. After all, we share the same universe and are therefore shaped and bound by the same physical laws of nature. In fact, that's what some people fear the most, that the aliens could be just like us, that they could inflict upon us what we inflict upon members of our own species. The Sagans and Drake tried to get ahead of these concerns by emphasizing the improbability of interception. They stressed that even if the probes were to fall into the tentacles of a hostile intelligence in some distant future, they'd be too far away to pose a threat. But statistics and probability only get you so far because fear is a powerful emotion.
And may I say, so that we can have a somewhat warmer and livelier conversation as this meeting goes on. I can conceive of no nightmare as terrifying as establishing such communication with the so-called superior, or if you wish, advanced technology in outer space.
A year after the launch of Pioneer 11, the Arecibo Radio Observatory, located deep within the jungles of Puerto Rico, received a major facelift. The telescope was not only resurfaced to greatly increase its sensitivity, but also outfitted with a powerful transmitter. As it happens, the man in charge of the research center overseeing the facility was none other than Frank Drake. To celebrate the telescope's upgraded capabilities, Drake's assistant, Jane Allen, suggested they transmit an interstellar message during the upcoming rededication ceremony. Unlike the tangible Pioneer plaques, the Arecibo Message had to be communicated using invisible radio waves. Drake had previously experimented with the idea of transmitting an image coded in binary, and with the help of some colleagues and graduate students, he came up with this. Now, this may not look like much, but if we fill in all the zeros with black squares and all the ones with white squares, a highly pixelated image will emerge. I'll explain the different parts in just a moment, but first, it's important to understand how an image like this is converted into radio waves. It starts with a grid that in this case is 23 columns wide and 73 rows tall for a total of 1,679 cells. We then fill in the cells needed to create the image. Because the image is composed of only two shades, black and white, that means it's binary, and each cell can also be described as a binary digit, or bit for short. By convention, binary code is expressed using zeros and ones, but it works just as well with two different shapes, two different colors, two different rocks, or literally any combination of two contrasting values. In fact, that's why binary code is so frequently used to write interstellar messages. It's not because aliens are guaranteed to understand it. No, it's simply one of the least complicated methods of conveying information that we can imagine. Chinese is composed of thousands of characters, English has 26 letters, while decimal demands 10 unique numerals. Binary only requires 2. Not 2 letters, not 2 symbols, literally just 2 of something, which we call bits. For instance, instead of black and white squares, we could just as easily express this bitmap using 2 different frequencies. If a cell is black, that's one frequency. If it's white, that's another. There you go, that's all there's to it. This long sequence of 2 flip-flopping frequencies can now be transmitted using a radio telescope. When that signal is picked up by an alien astronomer, they may find it difficult to ascribe such an unnatural pattern to a natural source. This will hopefully draw attention to the number of frequency fluctuations because 1679 is what's known as a semi-prime. It's disappointingly not the half-brother of Optimus Prime, but rather the product of precisely 2 prime numbers. In this case, those prime numbers are 23 and 73, which happens to be the dimensions of the original grid. If the aliens were to plot the frequencies onto a grid of that size and fill in all the cells occupied by one of the values, they would uncover the image. As for the contents of the message, it starts off easy enough with the numbers 1 through 10 expressed in binary and written from right to left, so 001, 010, 011, and so on. Moving on to this large cluster of pixels, we find a bunch of binary formulations for the building blocks of life as we know it. It starts with the atomic numbers of 5 basic elements: hydrogen, carbon, nitrogen, oxygen, and phosphorus. These numbers are then used to describe essential components of DNA. For instance, a carbon atom has 6 protons, which means it has an atomic number of 6. 0110 is binary for decimal 6. Because carbon is in the second column from the right, it means the second column of these molecules underneath indicates how many carbon atoms they contain. So these 4 represent an organic compound known as deoxyribose, which has 5 carbon atoms, and 101 is binary for decimal 5. In the center of the image, we find a crude rendition of the DNA double helix enclosing a large binary value denoting the number of nucleotide base pairs in the human genome. In simpler terms, it's a way of expressing the complexity or size of our genetic makeup. However, more recent measurements have since reduced that number by over 1 billion, so this figure is no longer accurate. A bit further down, we find a simple sketch of a human alongside an expression of their height on the right and the estimated global population in 1974 on the left. Directly underneath the human is a schematic of the solar system, followed by an illustration of the Arecibo telescope. Now, you might be wondering, how the hell were the aliens supposed to understand any of that? The simple answer is, they weren't really. Unlike the pioneer Plaques' commendable attempt to establish some sort of common ground using shared units of measurement and a galactic map of pulsars, the Arecibo message was much more of a publicity stunt. For instance, the length of the message was largely determined by the presumed attention span of those invited to the rededication ceremony. The concern was that if the message was too long, attendees might be annoyed by the sound of the transmission, which was planned to be broadcast over loudspeakers at the event. In the end, the message was constrained to about 3 minutes to mitigate the risk of a dull afternoon. Likewise, the selection of a target for the transmission was entirely dictated by what happened to be visible in the sky during the ceremony. Drake ultimately selected a bright cluster of stars known as Messier 13, which is about 24,000 light-years from Earth. While this meant the message would take 24,000 years to reach its destination, the density of M13 also meant the signal could sweep over many thousands of stars upon arrival. At the time, this was thought to maximize the odds of the transmission being received, and 𝐂𝐫𝐞𝐝 even told a reporter that he believed there was a 50% chance that M13 was home to an alien civilization. But as it turns out, more stars does not necessarily mean more opportunities for life. Not only are globular clusters like M13 typically starved of heavier elements essential for planetary formation, but the proximity of the stars makes it challenging for any planets that do form to maintain stable orbits. Considering it took billions of years before humans evolved on Earth, a region as densely packed and chaotic as M13 is probably not the most conducive environment for life as we know it. While there is some optimism that small planets like Earth could survive in very tight orbits, out of 6,000 exoplanets discovered to date, only 2 are located within a globuluster. Nevertheless, on November 16, 1974, a small crowd of astronomers, dignitaries and others bopped along to a 3-minute concert of 2 warbling tones as humanity's first interstellar radio telegram was beamed into space. A common misconception about the Arecibo message is that it will miss its target because the telescope was aimed at the position of M13 at the time of transmission rather than where it will be in 24,000 years. In reality, when Drake crunched the numbers back in 1974, he realized that the cluster is so enormous and slow-moving that even if they aimed the telescope at its location at the time, the message would simply strike slightly off-center rather than a bullseye. Presuming against all odds that M13 is home to an alien civilization in possession of an extremely sensitive instrument that's not only designed to pick up radio waves at the exact same frequency and bandwidth at which the Arecibo message was transmitted, but also pointed squarely at the solar system at just the right time, Messerian astronomers will have a non-zero chance to detect a non-repeating burst of energy lasting for less than 3 minutes, some 24,000 years from now. Even though they're unlikely to decode the message, they might still suspect it's an attempt at communication. It's a bit like, even if you don't speak Swedish, så kan du fortfarande förstå att någon försöker kommunicera. If they suspect it's a transmission from another civilization, the aliens may choose to respond. Presuming there's no way to overcome the speed of light, such a response would obviously take just as long to reach us as it took the Arecibo message to reach them. Based on the most recent measurements of the distance between the solar system and M13, the earliest possible date we can expect a reply is the year 50,370. Don't forget to mark your calendars. There are even more hopelessly optimistic scenarios like a star or spaceship crossing paths with a signal somewhere along the way, but the odds of that happening are so vanishingly small it might as well be impossible. Not least of all because, as you can see, M13 is actually floating far above the galactic disk, and there's a whole lot of nothing in between. But once again, these astronomical improbabilities were not enough to allay concerns of an alien invasion. A prominent radio astronomer in Britain at the time, Sir Martin Ryle, feared the Arecibo Message might attract a more advanced civilization seeking to colonize the Earth and mine its resources. He took issue with the fact that a small group of people had transmitted a message that could endanger all of humanity and called for an international discussion in advance of any future transmissions. While these concerns largely fell on deaf ears at the time, Ryle was far from the only one urging caution.
While the target star cluster in this instance is so far away that no reply would be received for 48,000 years, the temptation will be great to send more messages to closer stars. Have we really thought through the possible consequences of calling ourselves to the attention of a civilization superior to our own?
By the mid-1970s, NASA was gearing up to launch two spacecraft known as Voyager 1 and 2. Much like the Pioneer probes before them, the Voyager twins would be slingshot into deep space by Granddaddy Jupiter on their way to explore the outer solar system. Due to the similarity between the two programs and the public interest generated by the Pioneer Plaques, NASA engineer John Cassani thought a similar message ought to be carried by the Voyagers. When Cassani reached out to Carl Sagan in late 1976, he jumped at the chance to scribe another cosmic postcard. But this time he wanted to impress upon the recipients not just how we think, but also how we feel. After consulting numerous people on how to proceed, two propositions stood above the rest: music and pictures. Sagan was partial to music, while fellow astronomer Frank Drake thought nothing could capture the human condition like a series of photographs. After some additional brainstorming, it was Drake who finally realized they could accommodate both ideas using a phonograph record. A phonograph record is an analog storage medium primarily used to record and replay sound. To record, you simply press a needle against the surface of a slow-spinning disc. By generating a sound like strumming a guitar, the needle will start to vibrate as it carves a thin, undulating groove into the disc. To replay the sound, you simply create a copy of the disc using a less malleable material, place the needle back at the beginning of the groove, and spin the disc back up again. As the needle collides with the hundreds of microscopic indentations in the groove, it generates the same vibrations used to create it. When those vibrations reach your ears, you'll hear a guitar being strummed. The process is a bit more complicated in practice, of course, but honestly, not by much. Whether it's a single vibrating guitar string or the deafening crescendo of an entire orchestra, all of it can be recorded and replayed by tiny bumps in a groove. Yes, magic is real, and this is it. But what about photographs? How do you get visual information onto a storage medium made for sound? It's surprisingly simple, actually. Remember how the Arecibo Message painted a picture by treating black and white squares as two different frequencies? I mean, it would be a bit concerning if you don't. That was like 12 minutes ago. You better get that checked out. Anyway, they basically did that, but instead of just two frequencies, they used a whole range of them. Take a gradient like this, for instance. If we assign a low frequency to black and a high frequency to white, then every shade of gray in between will be mapped to a corresponding frequency of sound. With that translation scheme in mind, converting an entire photograph becomes trivial. For instance, this is a black and white image of Mercury that's actually on the record. All we have to do is scan every pixel in this image, one by one, column by column and translate every shade of gray into its audible equivalent. Once we've translated every frequency of light into a frequency of sound, we end up with a brief sample of incoherent noise that acts like an acoustic fingerprint of the image. Again, I'm simplifying a lot here, and the actual process used analog signals rather than quantized pixel values, but it gives you a rough idea of how it was done. Some photographs were actually recorded 3 times in a row using filters for red, green, and blue. When recombined in just the right way, they produce an image full of vibrant colors, even though individually they're all black and white. Again, magic is real. In an effort to save space, they also recorded 2 simultaneous streams of images into the same groove. This was accomplished by using the side-to-side motion of the needle to record one stream and the up and down motion to record another. The end result was this echoey stereo sound of 2 image streams playing at once. To provide the aliens with the best possible chance of decoding this cryptic disc of gold-plated copper, the record's aluminum cover was engraved with some basic instructions. First of all, the pulsar map makes a return, and so too does the diagram showing the hyperfine transition of neutral hydrogen, the latter of which is once again used to establish a shared unit of both time and length. Near the top left, we find an overhead view of the record, circumscribed by a binary number. It's telling the aliens to spin the record about 5 billion times faster than the hyperfine transition period. In human terms, that's equivalent to roughly 1 rotation every 3.6 seconds. To ensure the aliens have something with which to play the record, a ceramic cartridge holding a diamond-tipped needle was attached to the mounting bracket. An outline of this cartridge has also been drawn along the right edge here to indicate the playback starting position. Underneath the overhead view, there's also a side view, accompanied by another binary number. This time, it's telling the aliens how long it takes to play one full side of the record, which is about 54 minutes. Moving on to the top right, we find a step-by-step guide for decoding the images. The waveform at the very top corresponds to 3 vertical slices of the record's first image, while the zigzag pattern underneath means the slices are meant to be stacked side by side, one after the other. As we already know, this angelic symphony of beeps and buzzings are mapped to different shades of grey according to a very specific translation scheme, a scheme the aliens are meant to reverse engineer with the help of these binary numbers. There are 3 slices labeled 1, 2, 3, and each one corresponds to roughly 8 milliseconds of audio. A full image is 512 slices wide and should form a rectangular shape with a 4:3 aspect ratio. Simple as that. On the off chance that the aliens should somehow be confused by these crystal clear instructions, the record's first image has also been outlined here at the bottom to show them what it's supposed to look like when properly decoded. In fact, this calibration circle is the very first piece of data the aliens would find on the record. It's followed by more than 100 images, starting with some basic math, units of measurement, and a speedrun of the human experience. The sequence ends with this image of a violin floating above a page of musical notation. It shows the beginning of a somber classical piece known as Cavatina, and once the image fades, legendary MC Ludwig von Beethoven kicks off the mixtape. But the minutes-long performance of Cavatina only plays for a few seconds before it's interrupted by even more beeps and buzzings. You see, 6 additional images were squeezed onto the record at the very last moment, including a written statement by then President of the United States, Jimmy Carter, and a tedious listing of nearly 100 members of Congress. This bureaucratic theme then segues back into audio with a speech by then Secretary General of the United Nations, Kurt Waldheim.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet. We step out of our solar system into the universe seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate. We know full well that our planet and all its inhabitants are but a small part of this immense universe that surrounds us, and it is with humility and hope that we take this step.
The aliens will then be treated to a series of greetings spoken in 58 different languages.
Konnichiwa, o genki desu ka?
Siyanibingelela maqhawe, sinifisela inkonzo ende.
Hälsningar från en dataprogrammerare i den lilla universitetsstaden Ithaca på planeten Jorden.
Silema Khemen.
धरती के वासियों की ओर से नमस्कार.
Hola y saludos a todos.
تحياتنا للأصدقاء في النجوم. يا ليت يجمعنا الزمان.
Shalom.
Salvete 𝐂𝐴𝐿𝐿 estis. Bonam erga vos voluntatem habemus, et pacem per astra ferimus.
各位都好吧，我们都很想念你们，有空请到这儿来玩。
Пересилаємо привіт із нашого світу, бажаємо щастя, здоров'я і многоя літа.
Hello from the children of planet Earth.
This is followed by various sounds of things like weather, animals, and technology, before the record ends with a playlist of nearly 90 minutes of music covering a vast array of instruments, styles, and cultures. It starts about halfway through the A side of the record with an uplifting composition by Johann Bach. After another 9 tracks, including a famous American rock single and many obscure folk songs from around the world, the music picks up again on the record's B-side with another banger by Johann Bach. After nearly an hour's worth of additional music from countries like Germany, Peru, Russia, China, and India, just to name a few, the golden record comes to a significant end with a full rendition of Beethoven's Cavatina. Nearly half a century later, Voyager 1 is now the most distant spacecraft ever launched. Even though it was preceded by the Pioneer probes by several years, and even its own twin by 2 weeks, Voyager 1 attained a greater escape velocity and, in a sense, overtaken them all. Amazingly, both Voyagers are still transmitting to this day, although they're fast approaching their operational limits. Once they go offline and fall out of range, they'll join their pioneering brethren in a timeless and destinationless trek between the stars. Because the interstellar medium is sparsely populated with tiny dust particles, the exposed surfaces of both the Pioneer plaques and the golden records will erode over time. While the former is somewhat protected by its inward-facing placement, it's still exposed to the vacuum of space. On the other hand, the golden records are firmly pressed up against the body of the spacecraft. According to one estimate, the outward-facing B-side could survive for at least a few billion years, whereas the lifespan of the concealed A-side is anyone's guess. It's not impossible that many tens or even hundreds of billions of years from now, all the photographs, greetings, and 1/3 of the music will still be intact. While the response to the golden records was overwhelmingly positive, they did nonetheless receive a bit of criticism. Much like before, some people were completely undeterred by the near impossibility of interception and feared the Voyagers might attract a hostile intelligence. Others focused more on the contents of the message because they felt it was disingenuous to paint humanity in such a positive light when war, crime, and cruelty are as much a part of the human condition as music, sports, and science. As one of the makers of the record, John Lomberg, so succinctly points out,
"More human beings have killed one another or starved to death than have written string quartets."
The decision to exclude the uglier sides of humanity was partly to avoid potential backlash from people here on Earth, but also an attempt to make us seem less hostile to any future recipients. While a mushroom cloud does convey a shameful yet significant part of who we are, it could also be perceived as a threat. On the other hand, the exclusion of such imagery could by itself be quite revealing as we expose our casual willingness to deceive through tactful omission. Dating profiles, job interviews, meeting someone for the first time. I don't know if this is what the Golden Records team had in mind, but being selective with the truth to make a good first impression, how terribly human of them. The 3 initiatives mentioned so far are likely to be the only ones you've heard of before. The Pioneer Plaques, the Arecibo Message, and especially the Golden Records generated immense public interest at the time and remain well known to this day. But our attempts to communicate with life beyond did not end with the Golden Records. In fact, just a few years later, the silence was broken yet again, and this time the target was so close, the minimum response time was measured not in eons, but decades. In early 1983, Japanese publishing company Shueisha was looking for ways to commemorate the 15th anniversary of their most popular manga anthology magazine known as Weekly Shonen Jump. Due to the recent success of the film E.T. by Steven Spielberg and the fact that 1983 had been declared the World Communications Year by the United Nations, they decided to launch a competition dubbed Call to the Cosmos. The prize was a trip across the Pacific to visit a large radio telescope in Stanford, California, from which a message would be transmitted to a nearby star system. To win, all you had to do was submit a proposal for what the message should say. With a readership in the millions, the magazine received nearly 50,000 message ideas from children across the country. These were then compiled into one abbreviated message, and 15 lucky winners were selected to tag along on the trip. For the selection of a transmission target, the organizers turned to 2 radio astronomers named Masaki Morimoto and Hisashi Hirabayashi. They eventually chose the star Altair because it's very bright and relatively close. It was also selected because the message was planned to be transmitted during an annual Japanese festival known as Tanabata, which celebrates the meeting of 2 celestial deities represented by the stars Vega and Altair. Furthermore, Morimoto and Hirabayashi were asked to create their own message, and after 3 days of work, they came up with this: a sequence of 13 bitmaps measuring 71 by 71 pixels that were clearly inspired by the Arecibo Message. The first 4 images depict things like natural numbers, prime numbers, basic math, common elements, the solar system, and essential building blocks of DNA. The next 8 illustrate the evolution of life from simple organisms to jellyfish, fish, amphibians, dinosaurs, apparently not Bigfoot, a family of humans, and a close-up of a woman's face. The final bitmap depicts a crude illustration of the Stanford radio telescope alongside information like its radius, wavelength of the transmission, and total number of bits in the message. We also find the word toast written in plain English. According to Hirabayashi, during the 3-day stint when he and Morimoto conceived of these images, they weren't necessarily sober the whole way through. This may or may not have influenced their decision to include the Japanese and English word for toast, equated to the chemical formula for ethanol. Because Weekly Shonen Jump targets a very young demographic, the magazine tried to clean this up a bit by reframing what was clearly an afterthought by 2 half-drunk astronomers as
a toast between Japan and the United States.
Nevertheless, for about an hour on August 15, 1983, the 13 bitmaps and an audio recording of the abridged fan-submitted greetings were beamed towards Altair.
こんにちは、こんにちは、こんにちは。こちらは太陽系第3番目の惑星、地球です。この電波は青い宇宙船地球号からまだ会ったことのない友達、ET のあなたたちへ平和と友好の願いを込めて送信されました。この計画をして日本という国の多くの子供たちからメッセージが寄せられました。私たちの地球はもうすぐ新しい世紀を迎えます。その21世紀にはあなたたちと会えるかもしれません。だからさようならは言いません。もう一度友情の挨拶を送ります。こんにちは、こんにちは、こんにちは。
Altair is among the brightest stars in the night sky, and at a distance of less than 17 light-years, it's only, a few quadrillion stone throws away? In fact, Altair is so cosmically close that enough time has now passed for the transmission to have made a full round trip. That is to say, the message reached Altair back around the millennium shift, and we could have received the reply as early as 2017. Now, the fact that we never did does not necessarily mean there's nobody home. Perhaps they missed the brief 60-minute window when the message swept across their system. Perhaps they did pick it up, but they're still drafting a response. Perhaps they took one quick look at Earth and humanity and were like, nah, we're good. While all of these scenarios are of course equally probable, the most equal is unfortunately the first one. Not only have astronomers failed to detect a planet around Altair, but even if one does exist, the star's only been around for about 100 million years. Compare that to a 4.6 billion year veteran like the Sun, and things start to look a bit bleak. Sure, there's always the possibility that intelligent life typically evolves much faster than it did here on Earth, but we currently have no good reason to think that's the case. But it gets worse because even if the Altairians did respond, the odds of us even noticing are extremely remote, because telescopes are expensive, in low supply, and high demand. Sacrificing years, months, or even just days worth of observation time to screen a single planetless star for alien signals ain't exactly top priority. It wasn't until the summer of 2023 that a team led by astronomer Shinya Narasawa secured a brief time slot at the Yasuda Deep Space Center in Japan to search for a belated response to the Altair message. Scheduled once again to coincide with the annual Tanabata Festival, the search began late in the evening on August the 22nd and lasted for a grand total of 60 minutes. Remaining optimistic, Narasawa told reporters the following morning that they wouldn't immediately know if an alien signal had been detected because it would take a long time to analyze the terabytes of collected data. But given the lack of updates since then, I wouldn't keep my hopes up on this one. If nothing else, the message to Altair was received loud and clear by thousands of children across Japan. In fact, Call to the Cosmos seems to have had a bit of a rippling effect because a whole series of messages designed by Japanese children would later be transmitted for several years in a row. But before we get to all of that, we're going to take a brief detour into the dazzling world of censorship. As mentioned before, when the public became aware that NASA had bolted a plaque to the side of Pioneer 10, not everyone approved. But it wasn't just about the risk of attracting dangerous aliens, it was also about modesty. You see, some people were absolutely mortified to learn that the plaques featured line drawings of two naked humans engaged in the scandalous act of standing there.
I must say, I was shocked by the blatant display of both male and female sex organs on the front page of the Los Angeles Times. Surely, this type of sexual exploitation is below the standards our community has come to expect from the Times. Isn't it bad enough that we must tolerate the bombardment of pornography through the media of film and smut magazines? Isn't it bad enough that our own space agency officials have found it necessary to spread this filth even beyond our own solar system?
As amusing as that is, the controversy surrounding the plaque's nudity has been somewhat exaggerated over the years. These puritanical takes were muted and few, to quote 𝐒𝐿 Sagan, and it's genuinely difficult to find examples like the one you just heard. There were a handful of reductive headlines, and some newspapers opted for the Barbie and Ken doll treatment, but the vast majority published the full, uncensored image and barely even mentioned the couple. In fact, some criticized the Plaques not for showing the human form, but for not showing enough. More specifically, people took issue with the complete absence of visible female genitalia, considering that no such neutering had been applied to the man. It's unclear if the lack of anatomical detail on the lower half of the woman was demanded by prudish NASA officials or a decision made by the Sagans themselves. Conflicting accounts makes it difficult to know exactly who's to blame. Nevertheless, when it came time to select material for the Golden Records a few years later, these concerns flared up again. Fearing a repeat of the previous debacle, NASA religiously vetted every song, soundbite and image that 𝐒𝐫𝐞𝐽 sought to include. They ultimately rejected a nude photograph of a young man and pregnant woman intended to show both human anatomy and procreation. The reason I'm bringing this up is because in 1986, an American artist by the name of Joe Davis decided to fight back against all this pearl-clutching with a project known as Poetica Vaginal. With the help of a few ballerinas and other volunteers, Davis used a custom-made device to record, how do I put this? Contractions from within the female reproductive system. Those pressure oscillations were then artistically manipulated to create something that's meant to resemble human speech. After obtaining access to a radio telescope near the Massachusetts Institute of Technology, Davis and his team began transmitting the sounds into space. However, the broadcast only lasted for about 15 to 20 minutes before the project was prematurely terminated by an Air Force colonel who was apparently overseeing the facility. Nevertheless, according to Davis, those few minutes were enough to transmit brief snippets of audio to each of the 4 selected targets. 2 of them were never publicly identified as far as I can tell, while the other 2 are known as Epsilon Eridani and Tau Ceti. Epsilon Eridani is home to one confirmed planet with a mass nearly identical to that of Jupiter. While additional planets could exist, including ones that resemble Earth, Eridani is a relative newcomer to the Milky Way family at approximately 500 million years young. On the other hand, Tau Ceti is certifiably ancient. Its precise age remains unclear, but it's definitely older than the Sun and home to not just 1 but 4 confirmed planets. On top of that, there's a slim chance that 2 of them are grazing the inner and outer bounds of the habitable zone, that being the distance from the star at which water could remain liquid on the surface of an Earth-like planet. Unfortunately, both of these stars are surrounded by immense belts of debris, not unlike the asteroid and Kuiper belts in the solar system. The difference is that Epsilon Eridani and Tau Ceti retain asteroidal and cometary populations many times greater than what currently orbits the Sun. While this makes perfect sense for a youngster like Eridani, it's a lot more concerning for a galactic grandparent like Tau Ceti. It implies that something is either preventing that material from coalescing into planets across billions of years, or that the system has suffered a recent cascade of instability. In either case, more stuff almost certainly means more impact events, like the one that nearly wiped out the dinosaurs. But even if we optimistically assume that none of that's a problem, the mass and size of the planets orbiting Tau Ceti are highly uncertain. There's a good chance they have less in common with Earth, and more so with Uranus and Neptune. But even if that isn't the case, the chemical makeup of Tau Ceti appears to be quite different from the Sun, suggesting its planets are composed of materials quite different from those that spawned life in the solar system. In summary, it's not looking great. Now, it may seem pointless to consider the habitability of these distant worlds when the message we send towards them is completely indecipherable. I mean, if you thought the aliens were going to struggle with the Golden Records, good luck to them figuring this out. But just like the Arecibo Message, the artificial nature of the signal is a message in and of itself. If you want to believe there's a naturally occurring phenomenon capable of producing the exact same radio waves as those emitted by Joe Davis and his team back in 1986, you go right ahead. But somehow I have my doubts about that. Presuming the message was received and correctly identified as a technosignature, we could have received a reply from the Eridanians as early as 2007, or the Cetinites as early as 2010. I did some checking and regretfully have to inform you that humanity's been ghosted once again. About a decade after the message to Altair, the National Space Development Agency of Japan began hosting an annual space camp event for young children known as the Cosmic College. Students could choose from a bunch of different activities over the course of multiple days, including a class on how to write and send interstellar messages. In fact, one of the astronomers invited to lecture at these events was none other than Hisashi Hirabayashi, one of the creators of the Altair message. But it wasn't just a theoretical exercise. NASDA actually arranged for some of those messages to be transmitted into space. Once a year, between at least 1995 and 1998, simple bitmap images measuring 11 by 11 pixels were sent from the Yasuda Deep Space Center to various locations across the galaxy. These transmissions received next to no publicity at the time and are virtually unknown to this day. This makes it difficult to know exactly what was sent where and when. Here's what we do know. The first Cosmic College was held in August 1995, during which this image of two parents and a child was beamed towards some unknown destination within the constellation Libra. Even less is known about this image of an alien holding hands with a human, transmitted sometime in August 1996. This time we don't even know the general region of the sky to which it might have been sent. In August 1997, two bitmaps were beamed towards a binary star system known as Spica. The first image depicts a smiley face, while the other shows a Japanese dumpling known as a dango next to a steaming cup of tea. Unfortunately, Spica is a ticking time bomb because the two stars are expected to slowly encroach upon one another, which could trigger a supernova at some point in the future. Even if that wasn't the case, they're far too young to host an Earth-like planet, and even if that wasn't the case, it would take another 5 centuries for any replies to reach us. Finally, this image that simply says 1 + 1 = 2 was transmitted to some unknown location in August 1998. Now, there could be more of these transmissions that have been lost to time. For instance, an image of a leaf to symbolize the nature of Earth appears to have been designed during the Cosmic College of 1999, but I couldn't find any information on whether it was actually beamed into space. While competitions, art projects, and recreational programs certainly could generate an alien response, their primary function is to elicit a response from us down here on Earth. They're inspiring, provocative, and generally attract a lot of attention. So it was only a matter of time before someone came along and began charging a fee. In early 1998, American entrepreneur Charles Chafer announced a commercial venture known as Encounter 2001. The project sought to crowdfund the launch of a tiny, light-sailing spacecraft that would carry samples of human DNA beyond the solar system. For only $50, anyone could submit a few strands of hair along with a brief message and their portrait and join the so-called Millennial Voyage. Market analysis by Chafer and his team projected sales of anywhere between 1.5 and 4.5 million tickets before the launch date. If those figures seem a bit optimistic, they were nothing compared to the expectations of their customers.
Me and my girlfriend can't have children, and in a deep philosophical way, this may be one way for my genetic makeup to live on, with a minute chance that it might be recovered by another species and we might be recreated, and I could fall in love with my girlfriend all over again on another planet.
This idea that aliens might one day use your DNA to clone your body was surprisingly prevalent. For instance, the greeting submitted by renowned science fiction author Sir Arthur C. Clarke simply read, "Farewell, my clone." While the Millennial Voyage was the project's main objective, they also promised to beam participants' greetings into space ahead of the launch using a radio telescope, a side project that would come to be known as the Cosmic Calls. By spring of 1999, some 43,000 people had signed up for Encounter 2001, including 2 Canadian astrophysicists named Yvan de Til and Stéphane Demas. De Til and Demas had been given the task of creating what's known as a primer. A primer attempts to gradually introduce the recipients to more complex ideas using some sort of step-by-step process. For instance, the primer to the message to Altair were the 13 bitmaps sent alongside the far more complicated greeting in Japanese. De Til and Demas did something similar for the Cosmic Calls. They created a primer composed of 23 bitmaps and this first one starts off by listing the 10 digits of our decimal system using 3 different notations: unary, binary, and decimal. An idea they appear to have lifted from this image on the golden records, which did almost the exact same thing. But there is of course one very noticeable difference. The one from the golden records uses the familiar glyphs of Arabic numerals, whereas the primer to the 𝐂𝐫𝐞𝐽 uses these alien-looking symbols. That's because the Till and the Ma decided to create their own rudimentary language of sorts. Now, this might seem like an odd choice because whether, say, a 2 looks like this or like this, it's not going to make any difference to the recipients. But it's not about readability, it's about redundancy. You see, there's a lot of naturally occurring radiation that could interfere with the radio transmission between the source and destination. Imagine, for instance, that we transmitted 15 bits arranged like this to represent the number 8. If this one bit in the middle was flipped along the way, the recipients would pick up a 0 instead of an 8. Flip this bit and the 8 becomes a 6. Flip these two and it becomes a 5. In other words, this transmission has no redundancy whatsoever. Lose one bit and the entire message could become corrupted. The glyphs created by the Till and the Ma were designed to be as fault-tolerant and noise-resistant as possible. There are several bits of difference between all the symbols, and that still holds true even if they were to be mirrored or rotated. But apart from the symbolic difference, the 𝐂𝐫𝐞𝐽 primer follows a structure that should be very familiar at this point. The first 5 pages cover various mathematical concepts that gradually increase in complexity. The next 6 delve into chemistry and physics, including a schematic of the solar system. The next 8 are all about Earth, humanity, and biology, including a rendition of the pioneer couple and a 2-page map of the continents. Page 21 contains information about the transmission and telescope, while page 22 brags about our cosmological knowledge, like the age of the universe. The 23rd and final page invites the aliens to respond by asking them a series of questions using this flower-looking glyph as a stand-in for a question mark. For instance, this means velocity, while this means photon, so this question could be read as, what is the speed of light? But how could the aliens possibly know that these symbols mean question, velocity, and photon? Well, it all comes down to that first page of numbers to which everything else is anchored. The aliens would start by hypothesizing that these 10 symbols represent 10 digits in a base 10 numeral system. With that assumption locked in place, they'd move on to the next page and find 1 something 1 equals 2. Okay, so they now suspect that this symbol represents addition and make similar assumptions regarding subtraction, multiplication, and division. Once they get to page 4, they'd know that this reads something plus 2 equals 3, while this reads something plus 4 equals 10. Given that the same symbol is used to represent what is clearly not the same value, they might suspect that this is a placeholder for a variable quantity. In other words, this variable represents something unknown, a bit like a question mark, emphasized by this symbol off to the left. By gradually introducing new symbols alongside familiar ones in such a way that logic and process of elimination can be used to fill in the blanks, it creates a lot of mutual corroboration between the pages. By page 8, they'd be introduced to the concepts of time and length via hydrogen, followed by velocity and photons via the speed of light. To be clear, there's still plenty of room for confusion and misinterpretation, not least of all because a few typos did actually slip through the cracks. For instance, according to this line on the 7th page, uranium is said to have 116 neutrons, but there is no such element. The lightest known isotope of uranium has 122 neutrons, and the most abundant here on Earth has 146, which is probably what they meant. But even if the primer had been flawless, there's only so much hand-holding one can do when you don't even know if the recipients have hands. In addition to the primer, the language created by the Till and the Ma was used to write the message about the Millennial Voyage. This was followed by a copy of the Arecibo Message, greetings by the staff at Encounter 2001, as well as the 43,000 names and greetings from people around the world. With assistance from prominent Russian astronomer Alexander Zaitsev, Schaefer and his team then obtained access to the 𝐂𝐫𝐞𝐝 Deep Space Center in southern Ukraine, and the first cosmic call began broadcasting on May the 24th, 1999.
Greetings from Terra, or Earth, the third planet in the Sol system. As a member of the human race, I would like to extend goodwill to you and your race.
Give us a couple 100,000 years before you plan to visit us, please. Right now, we would have to run around saying, excuse the mess.
I hope the International Space Station program will succeed. I hope peaceful universe, and I hope we can find friends in the universe.
This message comes from 5th grade students of Earth, the third planet from the Sun, and part of the Milky Way galaxy. We are peaceful humans. Please answer.
There is life and diversity everywhere you look on our world. I hope the same is true on your world. Life should be common and treasured.
Caution. We humans are a confusing and confused group of bipeds. We need guidance and desperately seek help for our very survival. We offer versatility, curiosity, humor, fear, and love.
Unlike many previous initiatives, which received very little attention from the press and public, the cosmic calls were a global phenomenon. In fact, the project received so much attention that officials at the National Space Agency of Ukraine got a bit spooked. The plan was to beam the message to 4 nearby star systems, but after the first transmission on May the 24th, Ukrainian officials suddenly shut the whole thing down. According to Zaitsev, rumors had begun circulating that the reason Encounter 2001 were using the 𝐂𝐫𝐞𝐝 Deep Space Center was because they'd been denied access to American facilities out of concern it might be dangerous to transmit messages into space. In reality, other radio observatories like Arecibo were simply not available on the dates requested. It had nothing to do with malevolent aliens. Zaitsev spent over a month explaining this to the agency before Schaefer and his team were allowed to resume broadcasting on the last day of June. The first target was 16 Cygni A, a sun-like star that's part of a ternary system. In other words, it's a system of 3 stars, with Cygni A being encircled by a small red dwarf labeled C, and together they orbit another sun-like star labeled B that's nearly 6 times further away than Voyager 1 is from the Sun. While Cygni B does have 1 confirmed planet, it's an enormous gas giant that patrols the entire habitable zone, making it impossible for an Earth-like planet within that region to maintain a stable orbit. While the transmission was specifically directed at Cygni A, the situation doesn't improve much because, as far as we know, it doesn't have any planets. Instead, it's orbited by Cygni C at about twice the distance between the Sun and Pluto. It's definitely possible for an Earth-like planet to be sandwiched between them, but it all comes down to the precise orbit of Cygni C, which is currently unknown. The second target was Gliese 746, a binary system composed of a sun-like primary and a smaller companion of which very little is known. The distance between them is less than that between the Sun and Mercury, so there's no chance of finding an Earth-like planet in a stable orbit around either one. However, there is such a thing as circumbinary planets that orbit 2 stars at once. With a system as tightly bound as Gliese 746, there's plenty of space for such a planet to exist, but so far, nothing. The third target was 15 Sagittae. It could be described as a binary system because Sagittae A is orbited by this tiny companion labeled B, but Sagittae B is what's known as a brown dwarf that falls somewhere between a planet and a star. It's dozens of times more massive than all the planets in the solar system combined, but still not quite massive enough to shine like a star. Apart from Sagittae B, no other bodies have been detected, and the system is a bit on the younger side at approximately 2.5 billion years old. Finally, the fourth target was Gliese 777A, a sun-like star that is once again encircled by a red dwarf companion. Except this time the two are separated by such an enormous distance that it takes them upwards of 100,000 years to complete an orbit. Nevertheless, the target was 777A and it's home to 3 confirmed planets. 2 of them are many times more massive than Earth and are practically hugging the star, while the third is a bit more massive than Jupiter and is much further away. In between them lies the habitable zone, which does appear to be stable enough to host an Earth-like planet, but none have been detected to date. While all of these stars are within the general solar neighborhood, we still have to wait until the 22nd century until any response could relativistically be received. A fact that might come as a disappointment to some of you, but no doubt a relief to others.
You see, it's not that I'm paranoid. I feel that there will be many civilizations that want to be our friends. However, it only takes one with a contrary point of view to ruin our day, our existence. Before people start sending signals into space on my behalf, I'd like them to ask for my permission.
But it wasn't just the general public. A growing number of experts had begun to question the ethics and wisdom of deliberate communication attempts. Among them was Carl Sagan, who as early as 1983 began arguing in favor of listening rather than sending. Not so much because he feared invasion, but because he felt that contacting aliens was premature. He wrote that it is not yet clear that we have anything particularly interesting to say due to what he described as our backward status. In other words, a baby civilization like humanity probably won't have much to offer one that's been around for millions or billions of years, so we should prioritize intelligence gathering before we start shouting at the sky. But astronomers like Alexander Zaitsev strongly disagreed with that position, essentially arguing that we must not give in to fear of the unknown. Sure enough, just a few months after the first cosmic call, Zaitsev and others began work on yet another message. In early 2000, a youth community center in Moscow was preparing to host a festival to celebrate the new millennium. During the preparations, an astronomy teacher named Boris Chanichner suggested to some of his students that they should create an interstellar message to be presented during a space-themed portion of the event. The project was spearheaded by two teenagers named Igor Kiselev and Vladimir Filipov, who quickly devised a message composed of both music and pictures. Once the project had been approved by a committee that included Alexander Zaitsev, it was decided to transmit the message sometime the following year to commemorate the 40th anniversary of the first crewed spaceflight by cosmonaut Yuri Gagarin in 1961. Zaitsev expanded upon the ideas of Kiselev and Filipov by suggesting the message be divided into three distinct signal types: constant, continuous, and discrete. The constant signal would be sent first to let the aliens know they've picked up something strange. That probing beacon would then transition into a continuous signal conveying the musical component of the message. Finally, two discrete frequencies would be used to broadcast binary coded images. According to Zaitsev, the three formats represented a language of nature, emotion, and logic. A total of 9 musical compositions were selected, and Zaitsev proposed using an electronic instrument known as a theremin, partly because it generates a smooth monophonic signal with minimal overtones, but also because the theremin was a Russian invention. The visual portion of the message was composed of 28 bitmaps primarily designed by Kiselev and Filipov. The first image depicts a wave within a circle, which is meant to convey to the aliens that the circle's diameter is equal to the wavelength of the transmission. If they correctly make that guess, the next image is meant to be scaled so that this circle with a human face in the center matches the diameter of the circle from the previous image. Doing so would enable them to decode other components like how this wavelength corresponds to a spectral absorption line of water. Without going into too much detail here, it's meant to highlight the significance of water to life here on Earth. While some of the illustrations try to convey information using science and logic, a lot of it was artistically motivated. Life inhabits the ocean, land, and atmosphere, represented by dolphins, humans, and birds, that the aliens will of course have no chance of deciphering. The 10 circles along the edge, numbered 1 through 10, not only symbolize our use of a base 10 numeral system, but also correspond to the next 10 images. The first of which is this side view of our galaxy with an arrow pointing at us. The second is a schematic of the solar system. The third gets a bit closer. The fourth gets closer still. Then there's a family, a house, and a close-up of a person. Towards the end, there's also a yin and yang symbol, 2 games of tic-tac-toe, and an illustration of the telescope used to transmit the message. But it doesn't end there, because the next image is the same emblem we saw before, except the 10 outlying circles have now been filled in with the 10 preceding images. Exactly why they're laid out in this circular pattern in this particular order, or even what function it all serves, I couldn't tell you. But again, the emblem was intended to be both informational and artistic. Following the emblem sequence, the next 3 images contain some text written in both Russian and English. Approximately 1,000 students between the ages of 13 and 18 participated in the project, and this is an extreme abbreviation of their many proposed greetings. It very innocently ends with,
"We wish you peace and love,"
signed by
the children from the earth.
The final 12-bit maps depict illustrations that we've already seen, each one captioned with a brief description in both Russian and English. They're meant to function as a sort of dictionary with the hopelessly optimistic goal of teaching the aliens how to read the aforementioned greeting. The 3 components of the message, starting with a probing signal, followed by the music and the 28-bit maps, were then transmitted from the 𝐿 Deep Space Center on August 29th, 2001. Much like the first cosmic call, the teenage message was transmitted multiple times over multiple days, this time to 6 different targets. The first one was 𝐿𝐸 797A, an as of yet planetless but sun-like star that forms a wide ternary system with 2 smaller companions. The second target was 37 Geminorum, a solitary sun-like star that has yet to show any signs of hosting a planetary system. Target number 3 was another sun-like star known as 47 Ursae Majoris, which is home to 3 confirmed planets. They all appear to be gas giants, and the one closest to the star is grazing the outer edge of the habitable zone. Because it's more than twice the mass of Jupiter, its immense gravity renders nearly the whole outer half of the habitable zone completely off limits. An Earth-like planet within this region simply wouldn't be able to maintain a stable orbit. But if such a planet were to be located further inwards, things look a lot more optimistic. The fourth target was 𝐿𝐸 547A. Once again, it's a sun-like star that forms a wide binary system with a small brown dwarf companion. Apart from that, no planets as of yet. Target number 5 was yet another sun-like star known as 𝐿𝐸 327 with no confirmed planets. It does, however, show signs of being surrounded by either one or multiple belts of debris, but the precise mass, composition, and extent of this debris remains to be seen. Finally, the 6th target was 𝐿𝐸 788. It is yet another solar analog with neither stellar nor planetary companions. All but one of the targets are more than 50 light-years away, so the minimum response time is over a century. The one exception is 47 Ursae Majoris at 45 light-years, so we could hear back from the Majorans as early as 2092. As the name Encounter 2001 would seem to imply, the Millennial Voyage was scheduled to launch by the end of 2001, but shortly before the start of that year, the project was quietly rebranded as Team Encounter. While it's difficult to know exactly what was going on behind the scenes, it seems like they vastly overestimated the public's interest in sending messages into space. As mentioned before, the team expected to attract somewhere between 1.5 and 4.5 million customers. A few months after launch, they had sold 45 tickets. While sales ramped up quite a bit before the first cosmic call, 43,000 customers was still a far cry from the millions they had anticipated. With such lackluster performance, the company had no choice but to push back the launch date of the Millennial Voyage by several years, and changed the name to Team Encounter. But even after significant delays, a few celebrity endorsements, and numerous attempts to get people interested, sales lagged behind expectations by a wide margin. By the summer of 2003, the company's main investor finally pulled the plug, and the project was summarily abandoned. While this meant the Millennial Voyage was dead, Team Encounter did at the very least uphold their promise of transmitting a second cosmic call, the composition of which was very similar to the first. Just like before, it started with a primer designed by Yvan de Til and Stéphane Demas. However, they actually created a new set of glyphs, even more noise-resistant than the first. The 23 bitmaps were also redesigned and combined into one large image, but the contents of the primer stayed more or less the same. This was followed by a copy of the Arecibo Message, a few images from the Teenage Message, a description of the now cancelled Millennial Voyage, and greetings by the staff at Team Encounter. Last but not least was the commercial payload. This included not just the names and greetings of more than 100,000 customers, but also more unique contributions like a chatbot program called Ella, the contents of an entire website, and the song Starman by David Bowie. All of which was of course converted into binary before being transmitted into space from the Eupatoria Deep Space Center on July 6, 2003.
The people of the planet Earth send their greetings and friendship to you across light years of interstellar space. The message we send to you today contains information about our solar system, our planet, and ourselves. We invite you to contact us and to share your knowledge, culture, and wisdom. May this cosmic call open an exciting dialogue between our two stars here in the Milky Way galaxy.
Much like the first cosmic call, the second was beamed towards multiple targets. There were 5 in total, and the first one was 𝐿ISA 67. It's a binary system composed of a Sun-like primary and a red dwarf companion that takes about 20 years to complete an orbit. While neither one is known to harbor any planets, and the distance between them is less than that between the Sun and Jupiter at closest approach, they're still far enough apart for an Earth-like planet within their respective habitable zones to maintain a stable orbit. The second target was 𝐿ISA 208A, which is only about half the size and mass of the Sun and forms a wide binary system with an even smaller companion. No planets as of yet, and it could be as young as 500 million years, which would make it unlikely to host a spacefaring civilization. Target number 3 was 55 Cancri A, a star that's a bit fainter and colder than the Sun with a distant red dwarf companion. It's the host of 5 confirmed planets, with the 4th one, dubbed Harriet, orbiting within the habitable zone. Now, because Harriet's mass is at least 3 times that of Neptune, it's not a very likely candidate for life as we know it. But it's not inconceivable for life to have emerged on an Earth-like moon in orbit around Harriet. Not only that, but it is possible for an Earth-like planet to maintain a stable orbit within the outer half of the habitable zone, although simulations suggest that such a planet is far more likely to have formed just outside of it. The 4th target was 47 Ursae Majoris, which was previously the target of the Teenage Message, making this the first time we've signaled the same star more than once. Finally, the 5th target was 𝐿ISA 49, which has a lot in common with the second target. It's a red dwarf about half the size and mass of the Sun that probably forms an extremely wide binary system with an even smaller companion. While a planet with a mass of more than 5 times that of Earth has been detected around the primary, it's unlikely to be habitable due to its proximity to the star. But even if that wasn't the case, the system is probably too young to host a communicative civilization in the first place. Nevertheless, 𝐿ISA 49 is the least distant of the 5 targets at 32 light-years, meaning any potential replies could reach us no sooner than 2067. Now, 2 years after the second cosmic call, in the small European Republic of San Marino, Hungarian astronomer Ivan Olmar proposed a 10-point scale for quantifying the risk of interstellar messages. According to this scale, a transmission like the Arecibo Message carries a risk of 8, which is characterized as a far-reaching threat to humanity. Meanwhile, the 2 cosmic calls and the Teenage Message supposedly carry a risk of 7, giving them a threat level of high. While the risk factor is partially determined by objective metrics like signal strength and duration, it's also based on the contents of a message. This makes the San Marino scale inherently subjective, and it also fails to consider other crucial factors like the distance to and habitability of the target. That being said, the creation of the San Marino scale is a fascinating development because it highlights just how contentious the transmission debate had become. Many prominent figures within the SETI community, that being the search for extraterrestrial intelligence, had become a lot more hesitant or outright opposed to what had come to be known as METI, Messaging Extraterrestrial Intelligence, a term coined by none other than Alexander Zaitsev during the creation of the teenage message. Pushing back against this growing opposition to METI, Zaitsev reasoned that in a galaxy where everyone is listening and no one is speaking, someone has to make the first move. He called attention to a poll showing that 78% of more than 140,000 SETI enthusiasts were in fact in support of METI. What he doesn't mention is that over half of those same respondents were still unsure if the aliens they were hoping to contact were more likely to be friendly or hostile. Throughout the 1990s, there was increasing demand within NASA to launch a mission to Pluto. At the time, it was the last unexplored planet of the solar system, and even our most powerful telescopes could resolve nothing but a nebulous disk. After numerous failed attempts to secure the necessary funding, the spacecraft New Horizons was successfully launched on January the 19th, 2006.
6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
After borrowing some extra speed from the almighty Jupiter, New Horizons finally caught up with Pluto in 2015. At the time of the launch, Pluto was still recognized as a planet, but only 7 months into the mission, it was reclassified by the International Astronomical Union as a dwarf planet, a decision that remains somewhat controversial to this day. Although strictly semantically speaking, a dwarf planet is still a planet. It's right there in the name. Anyway, much like the Pioneer and Voyager probes, New Horizons continued on into deep space, destined to leave the solar system and roam the galaxy. Yet, unlike its predecessors, it does not carry a message. According to lead scientist Alan Stern, the inclusion of a plaque was brought up during the planning stages, but he ultimately rejected that proposal out of concern it might spark some sort of controversy that could take focus away from the mission. Not unlike what happened back in the 70s when actual adult human beings realized that underneath our clothes is not more clothes. Given that New Horizons was but the latest in a long series of failed attempts to launch a mission to Pluto, Stern did not want to risk yet another delay or worse. But as stern might have been regarding a deliberate message, he was not opposed to the inclusion of 9 symbolic items described as mementos placed within the nooks and crannies of the spacecraft. The most significant of which was this aluminum canister containing the ashes of Clyde Tombaugh, the American astronomer who discovered Pluto in 1930. Shortly before his passing in 1997, Tombaugh requested that his cremains be launched into space, and what better way to honor that request than to sail him past the planet that he discovered. The other 8 mementos included 2 flags of the United States, 2 state quarters, one from Maryland and one from Florida, honoring the states in which the probe was built and launched, a chunk of Spaceship One paying tribute to the first successful crewed spaceflight by a private company, a postage stamp describing Pluto as the only planet not yet explored, an off-the-shelf CD on the port side loaded with the names of more than 400,000 people who signed up during an online campaign, and another CD on the starboard side loaded with notes and photographs of people responsible for designing, building, and launching New Horizons. According to Stern, these artifacts were more efforts of the heart than the head, and were intended for us here on Earth, not whomever might stumble upon the probe in the distant future. In fact, commercial CDs degrade over time and become unreadable within decades or a few centuries at most. Although those estimates assume an Earth-like environment, not a spacecraft floating through the vacuum of space while being shielded from a lot of otherwise damaging ultraviolet radiation by a thermal blanket. Somehow, longevity estimates for a CD being stored in those conditions never came up in the search results. Anyway, the lack of a deliberate physical message bothered some people enough that in 2013, one of the makers of the Golden Records, John Lomberg, launched a campaign to create a digital one. The idea was for people around the world to submit sounds, images, and other material that could be uploaded to one of the memory banks aboard the spacecraft. While there was a lot of public support for the project and Alan Stern was open to the idea, the One Earth message never materialized. After a failed Kickstarter campaign in 2017, Lomberg stated in 2020 that NASA had initially said yes, but later changed their minds. Even if the project had succeeded, the One Earth message would have been no less symbolic than the 9 mementos because just like a compact disc, computer memory degrades over time. Even in the most optimistic of circumstances, we're talking centuries, possibly a few millennia at best. While it is a bit disappointing that no deliberate, lasting message was included with New Horizons, let's not forget that the probe itself is a message, one that would provide any recipients with immediate confirmation that they're not alone. Although that's presuming, of course, the probe is ever found. As I'm recording this, New Horizons has not been directed towards any particular star system, but that could change in the future. Following its encounter with Pluto in 2015 and this malformed space potato in 2019, the probe is now gliding through empty space while astronomers keep searching for additional flyby targets. So far, none have been detected, but the probe has enough juice to keep going until at least the 2040s. So, a few decades from now, shortly before it runs out of power, NASA could choose to steer the probe towards a star system in its general direction of travel. While such a course-corrected voyage would still take untold eons and humanity could be long gone by the time it arrives, I think it would be quite exciting to know that one of our foremost ambassadors was headed for something rather than nothing. In early 2008, a man named Martin Lewis approached NASA with the idea of beaming the Beatles song Across the Universe, Across the Universe. As a Beatles historian, Lewis sought to commemorate the 40th anniversary of the song's recording, and NASA seems to have agreed because the year also happened to mark the 50th anniversary of the agency's founding. Using a massive antenna at a deep space communications complex located west of Madrid in the middle of Spain, the nearly 4-minute song was beamed towards Polaris, the famous North Star, on February 4th, 2008. Former Beatles member Paul McCartney approved of the message by saying,
"Send my love to the aliens."
But it's highly unlikely for Polaris to be inhabited. For one thing, it's not a solitary star, but a system of 3. The primary is a supergiant that's about 2,500 times brighter and nearly 50 times larger than the Sun. Placed at the center of the solar system, its radius would extend about halfway to Mercury. Meanwhile, its closest companion is a bit more massive than the Sun and takes nearly 30 years to complete an orbit. This tight-knit binary pair is then encircled by a third star that's many tens of Pluto orbits away. No planets have been discovered as of yet, but even if an Earth-like planet with a stable orbit could be found within one of the star's habitable zones, Polaris probably hasn't existed long enough for intelligent life to have emerged. While the 2 companions could be as old as 2 billion years, it seems like the primary has only been around for a few tens of millions. As if that was not bad enough, Across the Universe won't arrive until the middle of the 25th century because Polaris is more than 400 light years away. In the spring of 2008, the brand Doritos launched a campaign in the United Kingdom called "You Make It, We Play It." The idea was for members of the public to create a short commercial about Doritos, and the winning entry would not only be played on national television, but also beamed into space. From a radar station in the middle of Svalbard in the Arctic Circle, a 6-hour loop of the 30-second advert departed Earth on June 12, 2008. The target was once again 47 Ursae Majoris, meaning we've now dispatched 3 separate messages to this singular star. Presuming the Majorans are listening, they'll be hearing the teenage message in late 2046, the second cosmic call in late 2048, and an unprompted admission that we like to hasten our mortal doom by voluntarily consuming dusty triangles of death sometime in late 2053. Response time? Let's hope not. In the summer of 2008, a now-defunct social media platform named Bebo launched a project known as A Message from Earth. It primarily functioned as a publicity stunt to advertise the website, and like so many initiatives before it, crowdsourced the creation of a message by inviting its users to submit text and images. Some untold number of submissions, and several months later, the 501 most upvoted entries were beamed into space from the Eupatoria Deep Space Center on October 9, 2008.
Our bodies are made of bones. We have senses: smell, taste, sight, and touch. Without any of these things, we wouldn't live.
I love television. We watch animated cartoons and real-life drama on it. I could sit and watch television all day.
I wish I could be alive to see the day contact between the two worlds is made. I've been born way too early.
Considering that this was open to the internet, I strongly suspect many messages were a lot less sanitized than what we just heard. But since participation required you to be logged in and Bebo went offline in 2013, very little of A Message from Earth has been preserved. Nevertheless, the target was a red dwarf known as 𝐵𝐸 581 that's a lot smaller, lighter, fainter, and colder than the Sun. What this means is that an Earth-like planet within this system has to orbit very close to its star to receive the same amount of energy as the Earth. So close, in fact, that the outer edge of the habitable zone around 𝐵𝐸 581 is closer than Mercury is to the Sun by a wide margin. With planets orbiting so close, it makes them vulnerable to flaring events, and it just so happens that red dwarfs have a penchant for sudden bursts of radiation. Not only can these eruptions have a sterilizing effect on nearby planets, but if there's one thing that life on Earth does not appreciate, it's sudden and dramatic changes to the climate. Not that we would know anything about that now, would we? The good news is that 𝐵𝐸 581 has a better chance than most of hosting an Earth-like planet because it's very old and therefore a lot less active than many of its younger siblings. It's also quite close at less than 21 light-years, meaning a reply could arrive as early as 2049. Even more promising is that shortly before and after A Message from Earth was transmitted, astronomers discovered not just one, but 2 planets a few times more massive than Earth, orbiting within the star's habitable zone. Unfortunately, follow-up studies failed to corroborate those findings, suggesting the initially planet-looking signals were nothing more than noise. Unless additional planets can be found in the future, any remaining hope of life falls to the 3 confirmed planets that lie a bit further inward. However, due to their even greater proximity to the star with orbital periods of only a few days, chances are they're less Earth-like and more Mercury-like. To commemorate the 400th anniversary of astronomical contributions made by Galileo Galilei and Johannes Kepler in 1609, the United Nations, along with the International Astronomical Union, declared 2009 the International Year of Astronomy. Unsure of how best to celebrate this milestone, a representative of the Australian government reached out to a popular science magazine known as Cosmos. The magazine's editor-in-chief, Wilson da Silva, suggested they transmit an interstellar message during an upcoming annual event known as National Science Week. They were soon given the green light by the government, and after consulting a bunch of astronomers, NASA and others, Cosmos launched a website called Hello from Earth. The project was described by da Silva as Twitter to the stars because the idea was to allow anyone to submit a brief text message of no more than 160 characters in length. When the submission period came to a close less than 2 weeks later, the website had received nearly 26,000 messages. According to Da Silva, less than 1% of the comments contained some sort of rule-breaking content like profanity, slurs, and so on. They were also forced by NASA to remove anything deemed even remotely sexual or aggressive, like the word breast, and the phrase "all your bays are belong to us," which is just a line from an old video game that later became a meme. As someone who's old enough to have been around back when this meme was still popular, this might be one of the most depressing things I've ever had to explain in a video. Painful reminders that we're all stuck in a travelator towards eternal nothingness aside, once all the messages had been vetted and approved, they were transmitted from a large antenna at the Canberra Deep Space Communications Complex in the Australian southeast on August 28, 2009.
Hello from Australia, on the planet we call Earth. These messages express our people's dreams for the future. We want to share those dreams with you.
To be or not to be, that is the question.
I'd like to invite you all back to my place for a few beers.
Klaatu, Barada, Nikto.
Does the meaning of life equal 42? If not, please explain.
Please come and save us from ourselves.
Do you plan to invade?
Which way does the water spin when you flush the toilet?
How is it that you understand English? That's very convenient.
Hey guys, great to catch up the other day. We'll discuss intergalactic trade policy next week. Keep it on the hush-hush, remember?
We're no strangers to love. You know the rules, and so do I. A full commitment's what I'm thinking of. Never gonna give you up, never gonna let you down.
We are destroying our planet and are too selfish to stop. We need your help. Please, come quickly.
We're mostly harmless.
Do you have any updog on your planet?
Apologies in advance for most of these messages. They are an example of our primitive humour.
Live long and prosper.
Hello from planet Earth.
Much like A Message from Earth, Hello from Earth was also directed towards the nearby red dwarf Gliese 581. As mentioned before, observations conducted back then suggested the presence of two planets within the star's habitable zone, but those findings have since been refuted. Nevertheless, Gliese 581 is now the second star to be signaled more than once, after 47 Ursae Majoris. While the International Year of Astronomy was primarily dedicated to Galileo and Kepler, 2009 also marked the 35th anniversary of the Arecibo Message, something that American artist Joe Davis decided to celebrate in his own unique way. One of the most vital biological mechanisms on Earth is photosynthesis, the ability of some organisms like plants and algae to produce life-essential oxygen using water, sunlight, and carbon dioxide. Now, a crucial component of photosynthesis is a special molecule known as RuBisCO. RuBisCO is what's known as a protein, or more specifically an enzyme, that's been around for billions of years. Presuming the evolution of life here on Earth is typical rather than special, one possible way to communicate with an alien species would be to send them very basic biological information. If their path to intelligence bears any resemblance to our own, there's a chance they'll recognize an enzyme as ancient and rudimentary as RuBisCO. This was the idea that occurred to Joe Davis in late 2009, but instead of using something more conventional like binary code, he decided to map the RuBisCO gene sequence to 4 increasingly syllabic phrases alluding to an ancient Greek proverb. These were then vocalized and turned into a 15-minute audio sample using the text-to-speech feature on a regular iPhone. Now, if you feel like you couldn't quite follow all of that, no need to worry, there's zero chance the aliens will either. Much like Davis's previous project, the RuBisCO Stars message was largely symbolic and primarily intended to evoke a reaction from people here on Earth. Nevertheless, using his academic connections, Davis managed to book time at the Arecibo telescope. Then, on November 7th, 2009, just over a week before the 35th anniversary of the Arecibo Message, a frequency-shifted audio recording of a synthetic voice rattling off fragmentary sentences representing the RuBisCO gene sequence was beamed towards 3 nearby stars.
Know yourself. The riddle of life. I know yourself. I know yourself. I know yourself. Know yourself. Know yourself. I know yourself. Riddle of life. Know yourself. Riddle of life. Know yourself. I am the know yourself. Know yourself. Know yourself. Riddle of life. I know yourself. Know yourself. Riddle of life.
The first target was 𝐶Z Arietis, a red dwarf less than 15 light-years away with one confirmed planet approaching the mass of Saturn. It's a very active flare star, so even if an Earth-like planet could be found, it's unlikely to host life as we know it. Meanwhile, the third target was Kappa-1 Ceti, a Sun-like star barely 30 light-years from Earth. While it is similar to the Sun, it's also a lot younger, making it unlikely that sufficient time has elapsed for a communicative civilization to have emerged. But the second target is a lot more interesting. It's another red dwarf known as Teegarden star, and while it does exhibit occasional flaring, it's a lot older and much less active than most of its kind. Furthermore, it's home to 3 confirmed planets with masses very similar to that of Earth, and 2 of them orbit within the habitable zone. To quote a recent paper, they are among the most Earth-like exoplanets currently known. But Earth-like does not necessarily mean habitable, because flares are but one obstacle that red dwarf planets have to overcome. Another potential hazard is something known as tidal locking. Without going into too much detail, the simplest form of tidal locking is when the rotation of a celestial body becomes synchronized with its orbital period. The most famous example of this is the Moon. It completes precisely one rotation for every orbit around the Earth, which is why we only ever see one side of the Moon. The reason this happens is a bit complicated, but it's tied to proximity. The tighter the orbit, the more likely it is for a celestial body to become tidally locked to its host. As you can imagine, planets orbiting red dwarfs are especially susceptible, as they have to orbit very close to their star to retain liquid water on their surface. Sure enough, the 3 planets orbiting Teegarden star are all believed to be tidally locked, just like the Moon. This is less than ideal because it means that one hemisphere is cooked by everlasting starlight while the other is plunged into eternal night. Habitability estimates for such bisected worlds range from extremely pessimistic to cautiously optimistic, because some climate models suggest warm air from the day side creeps into the night side, which pushes cold air from the night side into the day side, and so on. The end result of which is a planet with a surprisingly temperate climate that keeps water at perfect equilibrium between freezing and evaporating. But even if we accept the more optimistic models, the proximity of red dwarf planets also makes them less likely to retain an atmosphere in the first place. That's because stars tend to shed vast quantities of material into space, and the closer you get, the more intense that stellar wind becomes. As if that was not bad enough, this wind is occasionally interrupted by more explosive events like coronal mass ejections that can expel billions of tons of superheated plasma in a matter of minutes. Here's one being ejected from the Sun, with the Earth hauntingly to scale. In the case of Teegarden star, the 2 innermost planets are between 9 and 15 times closer than Mercury is to the Sun. It only takes them 11 and 5 days respectively to complete an orbit. According to one recent study, that's close enough for the stellar winds alone to completely strip those planets of a lasting atmosphere. While atmospheric erosion could be mitigated by a strong magnetic field like the one that surrounds the Earth, the magnetosphere of tidally locked planets would likely be reduced by their sluggish rotation. All that being said, the habitability of red dwarf planets remain open to debate. There is so much we don't know, and theories, simulations, and mathematical models can only do so much to fill in the blanks. Red dwarfs account for approximately 3/4 of all stars in the Milky Way, so it would be a real shame if not a single one of them can support life as we know it. It's possible that some environments are conducive to life while others are not. The tricky part is determining where that line should be drawn. Presuming the planets orbiting Teegarden star have in fact cradled beings of sufficient intelligence, a reply to the RuBisCO stars message could be heading our way right this very moment. The signal would have reached the Teegardenese back in 2022, which amounts to a round-trip ETA of 2034. Don't forget to mark your calendars. No, genuinely this time. Late one evening on August 15th, 1977, the Big Ear Telescope in the US state of Ohio performed a routine survey of the sky. A few days later, a volunteer named Jerry Eman sat down to review the collected data. What he found was a signal so exceptionally strong that he encircled the sequence on the printout sheet and famously wrote "Wow" in the left-hand margin. The WOW signal remains a mystery to this day, not least of all because it was never detected again, despite numerous attempts to do so. The sequence 6𝐸𝐞𝐬J5 is not some sort of code, but merely the intensity of the signal over time, where numbers above 9 are represented by letters to save space. It makes a lot more sense if we plot it onto a graph like this. It begins with a value of 6, meaning it was 6 times more intense than normal background noise. The signal then jumped up to 14, followed by 26, and a peak intensity of 30 times above background. The signal then fell back to 19, and then 5, before it disappeared. Each of the 6 samples were recorded 12 seconds apart, and this 72-second rise and fall is perfectly consistent with the telescope panning over the source along with the Earth's rotation. In other words, the source of the WOW signal appears to have been more or less fixed in the night sky, much like a distant star. Had it been an Earthbound source, it would have moved with the telescope, while things like airplanes and satellites would likely have moved too fast to remain visible for the whole 72 seconds. The WOW signal was also tantalizingly close to the frequency of the aforementioned hydrogen line. This makes it even less likely to be man-made because it falls within a protected band of frequencies reserved for radio astronomy. On top of that, it had a very narrow bandwidth. What this means is that unlike a star, for instance, which emits radiation across a wide spectrum of frequencies, the WOW signal was very focused. It's by no means impossible for a natural source to produce such a concentrated beam, but it is unusual. This is what makes the WOW signal so curious. It bears all the hallmarks of a technosignature. Just as we have identified hydrogen, the most abundant element in the universe, as a means of initiating contact, the aliens could have done the same. Just as we tend to transmit extremely brief, non-repeating messages, the aliens could be doing the same. Unfortunately, the peculiar design of the Big Ear telescope makes it impossible to pinpoint the source of the signal. The setup was such that 2 large swaths of sky were scanned simultaneously, but there's no way to tell them apart when looking at the data. Even more peculiar is that the signal was only detected once, despite this dual scanning design. This can only mean one of 2 things. Scenario 1 is that the source had been transmitting for some indeterminate amount of time ahead of the first scan, yet ceased transmitting before it could be detected again by the second. Scenario 2 is that the source began transmitting during the roughly 3-minute window between the 2 scans and continued to do so for who knows how long. Now, for a signal to carry information, it has to exhibit some sort of pattern. For instance, we tend to encode our messages by encoding a binary pattern that shifts back and forth between 2 different frequencies or levels of amplitude. The WOW signal did not exhibit any such pattern. Both its frequency and amplitude had a constant, unmodulated appearance throughout the whole thing. That being said, we can't rule out the possibility that a sequence of fluctuations were present, but that they fell below the threshold of what the Big Ear telescope could detect. No instrument has infinite resolution, and Big Ear had some quite significant blind spots. To quote Eamon,
"Any variation of signal amplitude within the 12-second interval would not have been detected. The signal could have been varying in any of a variety of ways, and we would not have seen it."
On the off chance that the WOW signal was a message from another civilization, the National Geographic Channel decided to transmit a reply on its 35th anniversary. After collecting over 17,000 tweets and about a dozen video-recorded greetings by various celebrities and public figures, the WOW reply was beamed into space from the Arecibo telescope on August 15th, 2012. At least, that is what the public was told. But after contacting someone who worked at Arecibo when this transmission took place, they told me that the stress of beaming thousands of messages into space had caused the aging transmitter to overheat and break down. They could not recall how many messages made it through, but it could have been as few as just a single one. Now, because the details of the project had already been publicized ahead of time and no correction was ever issued, everyone assumed that the WOW reply went off without a hitch. But not only is it unclear how many tweets were sent, it's also unclear where they went, because the WOW reply had 3 intended targets. They were all sun-like stars known as HD 54351, 37 Geminorum, and 55 Cancri A. Very little is known about the first, and it's quite some distance away at 140 light-years. Meanwhile, the other two are much closer and have both been targeted by previous METI experiments. The person I spoke to could not recall which one was targeted first, so my best guess is HD 54351 because that's the one listed first in a press release about the project. Now, with a name like WOW Reply, you'd think the three targets were located within one of the two regions from which the WOW signal is known to have originated. Well, if you did think that, it might be time to recalibrate your common sense because all three targets are not only located outside of these regions, but in the complete opposite direction. The reason for this is very simple. The location where the WOW signal was detected was beyond the reach of the upward-facing and stationary Arecibo telescope. But if that's the case, why even call it the WOW Reply in the first place? Apart from being transmitted on its 35th anniversary, none of this had anything to do with the WOW signal. While the signal does have the hallmarks of an alien transmission, there's still a very good chance it was caused by a natural phenomenon. It's just a matter of identifying the correct one. For instance, one recent hypothesis tried to blame the whole episode on a pair of passing comets, but like all previous explanations, this one has failed to withstand further scrutiny. More recently, a paper published in 2024 hypothesized that a powerful flare ejected by something like a magnetar could have been amplified by a cloud of hydrogen, which would explain the signal's frequency. Whether this is the solution that will finally crack the case or be relegated to the mounting list of dead ends, only time will tell. In the early 2010s, a film editor named Pierre Fabre conceived of a project dubbed Lone Signal. Much like Team Encounter and the Cosmic Calls, Lone Signal was an attempt to commercialize interstellar messaging. The project was envisioned as a social media platform where anyone could submit text, images, audio, and video for direct transmission into space. Another similarity between Lone Signal and the Cosmic Calls was the inclusion of a primer written in a mathematical language of sorts. Constructed by planetary scientist Michael Bush, every component of this language is represented by a string of 8 digits between 0 and 7. For instance, 1 + 1 = 2 looks like this, and here on the right is an example of some basic algebra. Things only become more complicated from there, but I'll spare you the details because according to Bush, the technique used to encode the primer into the signal was far too fragile to survive the years-long trip across interstellar space. While the signal could still be detected, any patterns would become scrambled along the way, making it impossible to extract and decode the primer at the destination. In other words, alien astronomers may end up with their own WOW signal that doesn't seem to fluctuate in any meaningful way, yet whose properties may still be difficult to ascribe to a natural source. Now, what truly sets Lone Signal apart from every other initiative mentioned so far is that it wasn't a one-time thing. Instead of transmitting the primer and public greetings all in one go, Lone Signal sought to establish a permanent beacon that would continuously transmit for years or even decades. To make that happen, they couldn't just book time at an active observatory, but had to obtain long-term exclusive control over a telescope. After shopping around for a bit, they eventually secured a 30-year lease on a decommissioned telescope in southwestern California called the Jamesburg Earth Station. Then, after upgrading some of its aging equipment, Lone Signal began transmitting on June 17, 2013. But the team behind Lone Signal had even greater ambitions. Their long-term plan was to raise $100 million and to establish a network of telescopes to continuously signal multiple targets all at once. They likened themselves to SpaceX and hoped to create a global platform from which anyone in the world could beam any random thought directly into space all day long. But in a classic case of history repeating itself, the team behind Lone Signal, much like Team Encounter before them, vastly overestimated the public's interest in METI. Less than 2 months after launch, revenue from the website barely covered 2% of their operational costs. Pierre Fabre later wrote in a comment, "We failed to connect with our audience on a colossal scale," and that failure led investors to ultimately pull the plug. Nevertheless, the transmission target was yet another red dwarf called Gliese 526. It's less than 18 light-years away and about twice as old as the Sun. While it is a relatively quiescent star with only occasional flaring, a planetary system has yet to be detected. Should it be home to a spacefaring civilization, they will have upwards of 2 months to notice our cosmic shouting beginning in early 2031. Back in prehistoric times, not long after you pressed play on this documentary, I mentioned a series of METI experiments carried out by the National Space Development Agency of Japan in the mid to late 1990s. Designed by young students attending a NASDA space camp, these 5 bitmap images were transmitted from the Yasuda Deep Space Center to various locations across the galaxy. Fast forward to 2013, and the successor to NASDA, the Japan Aerospace Exploration Agency, decided it was time to try again. During a similar space camp event and using the same telescope as before, JAXA retransmitted this image of 2 parents and a child on September 22, 2013. A similar bitmap depicting a human standing next to the sun was then transmitted the following year on August 23rd, although it's unclear exactly what it looked like. Nevertheless, both images were directed at 55 Cancri-A, which has been targeted in the past and discussed in more detail in a previous chapter. But much like what happened back in the 90s, the JAXA Space Camp messages flew as much through the radar as they did under it. Instead, these events were largely overshadowed by new developments in the ongoing transmission debate. Most notably, in early 2015, over 24 scientists and SETI enthusiasts, including a pre-disgraced Elon Musk, signed a petition calling for a worldwide consensus regarding METI. They took issue with the fact that past METI experiments had been based upon the wishes of a few individuals rather than a broadly representative body, in part because the aliens are likely to be millions of years more advanced than us, but also because it is impossible to predict whether they will be benign or hostile. The petition concluded that the potential consequences of contact demanded worldwide scientific, political, and humanitarian discussion in advance of any future transmissions. To which an artist in collaboration with the European Space Agency responded,
"Anyway, I started blasting. Bang, bang, bang."
In early 2016, an artist and independent researcher named Paul Quast created a crowdsourced art project known as A Simple Response to an Elemental Message. It was similar to previous initiatives, except this time people were asked to frame their submissions as an answer to the question, how will our present environmental interactions shape the future? As the question implies, the project was about climate change and sought to capture a global portrait of humanity's thoughts and feelings about the present and future state of the world. As explained by Quast in a few interviews, the project was intended more as a time capsule for future generations than any potential aliens in outer space. This is also reflected by the selection of Polaris as the transmission target. As mentioned in a previous chapter, it's a relatively young and currently planetless system that's highly unlikely to host life as we know it. Instead, Polaris was primarily selected due to its historical significance as the famous North Star. Nevertheless, A Simple Response to an Elemental Message received nearly 4,000 submissions over the course of about 8 months. In addition to the public messages, Quast also included a few copies of the Arecibo Message, 81 quotes by prominent figures, and 70 photographs of Earth and humanity, all of which was then converted into binary and finally blasted into space by the Cebreros Deep Space Ground Station in central Spain on October 10, 2016.
Our present environmental interactions are going to have us searching for a new home. So if there are any aliens out there renting out any space apartments, we'll be looking for 2 bedrooms, 2 bathrooms, and maybe a nice view of your 2 suns.
We have proven that a single species is chemically capable of altering the biosphere. Now we must prove that one is capable of amending it.
I think that if we were to challenge our ways now, it is unfortunately too late to remedy a solution for the future. The damage is done.
All of this concern for the future hinders optimism for what we have already achieved to secure it. We have progressively steered our civilization away from many existing threats.
The turning point of our time will be when our species achieves nuclear fusion to push us out of the era of carbon fuels and into a more sustainable society.
I am optimistic, and I am sure that humanity will be able to coexist with nature and in peace.
Our present interactions with the ecosystem will destroy human life long before Polaris gets this message.
According to a subsequent review by Quast, he found that just under 20% of the respondents were optimistic, just over 42% expressed some form of dread or concern, while the remaining 38% were largely neutral. In late 2017, a Spanish music festival known as Sónar began transmitting brief snippets of music into space to commemorate its 25th anniversary. Each composition was no more than 10 seconds in length and were provided by 38 musicians with connections to the festival. The first 18 were transmitted over the course of 3 days in October 2017 from a telescope located in the far north of Norway. The remaining batch of 20 was then transmitted over the course of another 3 days in May 2018 using the same facility.
State of mind.
What makes this initiative a bit more interesting, though, is the fact that all 38 compositions were preceded by a primer. In fact, not just one, but several. The first one began with 2 lists of prime numbers intended to attract attention. While the primes were technically expressed in binary, it would be more accurate to say that they're expressed in unary repeated twice. So 0011 for decimal 2, 000111 for decimal 3, 00001111 for decimal 5, and so on. This was followed by a simple count from 0 to 255, expressed using 8-digit chunks of binary code, also known as a byte. So it goes from 8 zeros representing 0, all the way up to 8 ones representing 255, the highest value possible using 8-bit encoding. Okay, following that introductory sequence was a second primer that differed between the 2 sessions. The one included with the first batch of music was written such that all 256 bytes represented a unique number, word, or concept. These bytes were then used to convey increasingly complex ideas, much the same way it's been done in previous initiatives, starting with some basic math before delving into things like physics and sound. The one included with the second batch of music was nearly identical to the one created by Yvonne Dutil and Stéphane Dumas for Cosmic Hall 2. Some of the components have been shuffled around and there's some updated information about the telescope, but otherwise it's exactly the same. Immediately following that was another bitmap that tried to graphically convey the concept of a byte by counting from 0 to 255 once again. This was then followed by an image of a sine wave intended to visually convey the concept of sound and music. Now, the target of these transmissions was an ancient red dwarf known as Luyten's star. It's a bit more than 12 light-years away and harbors 2 confirmed planets, the outermost of which, Luyten b, is about 3 times the mass of Earth and orbits within the star's habitable zone. In fact, it is one of the nearest Earth-like planets ever discovered, and it's the sole reason that this system was targeted. But as mentioned previously, the characteristic dimness of red dwarfs places the habitable zone very close to the star. In the case of Luyten b, it orbits about 4 times closer than Mercury orbits the Sun, takes less than 19 days to complete the revolution, and is all but guaranteed to be tidally locked. On the plus side, Luyten's star exhibits minimal flaring due to its advanced age. Presuming Luyten b is inhabited by an advanced civilization, they'd have about 11 minutes per day for 3 consecutive days in early 2030 to pick up the first batch of music, with the second arriving a few months later. Presuming they do so, we could hear back from the Luytenians as early as 2042. Okay, we have finally reached the most recent interstellar message as of the making of this documentary. Well, kind of. We'll get to that in a moment. Following the death of Stephen Hawking in early 2018, his ashes were interred at a famous church in London called Westminster Abbey. As the memorial service came to a close, an original score set against Hawking's iconic voice and written by Greek composer Vangelis was simultaneously beamed into space from the Cerberus Deep Space Ground Station on June 15, 2018. The target was a binary system nearly 5,000 light-years away, known as V616 Monocerotis. It's composed of a star about 1/3 the mass of the Sun and a black hole. At the time, it was the nearest black hole to the solar system, although it has since been dethroned by at least a few other candidates. Now, paying tribute to Stephen Hawking by beaming his voice into space may seem like an odd choice, considering he was a very outspoken critic of METI. But as explained by his daughter Lucy, the broadcast was a purely symbolic gesture intended not only to celebrate his scientific contributions, but also to fulfill his lifelong dream of going into space. This is further reflected by the transmission target, as Hawking dedicated much of his life to the study of black holes. Besides, we're hardly going to make contact with aliens in the vicinity of a black hole, right? Well, so about that. This is a view of the solar system, showing all 5 interstellar spacecraft that humanity has launched to date. If we zoom out a bit further, we can see 23 of the nearest star systems targeted by at least one of the radio transmissions mentioned in this video. But to see the 2 most distant targets, we have to zoom out to a galactic scale. Here we find V616 Monocerotis, the target of Stephen Hawking's memorial broadcast, and finally Messier 13, the target of the Arecibo Message. But this is by no means an exhaustive list. Some radio transmissions, marked here in gray, did not make the cut because they failed to meet one of 2 criteria that I made up for this video. The first one is that a transmission must be deliberately directed at an extrasolar target. After all, the goal of METI is to contact another intelligence, so projects that aimlessly blast messages into space with no particular target in mind do not count. This includes signals that could accidentally be detected, like those routinely transmitted by astronomers to communicate with spacecraft or map the surface of bodies within the solar system. To give you an example, in late 1962, a group of Soviet astronomers used this absolute beast of a telescope to bounce radar signals off the surface of Venus. For a bit of fun, they decided to modulate the radar pulses to spell out the words Mir, Lenin, and USSR using Morse code. This is sometimes described as the first interstellar message because a lot of that radiation went right past Venus and continued on into deep space. Now, if you read about this online, you'll find claims that some portion of that excess radiation is currently heading for an obscure binary system known as HD 131336 that's well over 1,000 light-years away. The phrasing can often make it seem as though this was planned by the original scientists back in 1962, but that is not the case. The true source of this claim is a forum post from 2002 in which an amateur astronomer did some quick back-of-the-napkin calculations to suggest HD 131336 might have been near the path of the signal depending on the precise time of transmission, which is unknown. Given the imprecision of that guesstimate and the fact that the intended target was Venus, I decided not to include it on my list. The second criterion is that the strength of a transmitted signal must be greater than 100 megawatts. Now, for any radio astronomers watching, here I'm not talking about output power, but the much more crucial parameter, which is the effective radiated power that accounts for things like transmission frequency and gain of the antenna. For anyone curious, you can find a spreadsheet in the references with all the incredibly exciting technical details. Anyway, there's nothing special about the 100 megawatts. I just needed some way to filter out some of the weaker transmissions from the stronger ones, and this seemed like a nice, even number to draw that line. It's neither so high that everything is excluded, nor so low that everything is included. It's just a way to rein in the scope of this video. While I tried to be as forgiving as possible with these 2 criteria, you could of course be a lot more strict. For instance, it is very common to categorize METI experiments based on how earnest or frivolous most experts perceive them to be. Take the Doritos broadcast project as an example. It is typically not regarded as a genuine attempt at METI because transmitting a commercial into space is obviously just a publicity stunt. It's rather silly, unscientific, and utterly indecipherable. To use the terminology favored by 𝐒𝐿EXANDER it's pseudo-METI. But as I've stressed multiple times throughout this video, what we say isn't all that important because we're probably not going to be understood anyway. What is important is that the signal has been modulated or manipulated in such a way that it does not resemble anything else in the universe. As long as the recipients are unable to ascribe the signal to a natural source, they will have no choice but to entertain the possibility of intelligent design. Besides, the distinction between genuine and pseudo-METI is highly subjective and inconsistent. For instance, the Arecibo Message is usually upheld as a prime example of METI, despite Frank Drake himself describing it as a publicity stunt, and much of it is indecipherable. Likewise, the message to Altair is typically regarded as genuine METI, even though the Doritos broadcast project was about 5 times more powerful and lasted 6 times longer. Another approach would be to sort METI experiments based on the distance to and habitability of the target. You could, for instance, exclude the Arecibo Message because M13 is extremely far away and unlikely to be habitable. Same thing with Stephen Hawking's memorial broadcast directed at a black hole many thousands of light years away. But here's where things get a bit tricky, because how do we determine when a target is too far away? In other words, how do we know when a signal is too weak or sufficiently strong to be detected by an alien civilization of which we know nothing about? The simplest approach would be to assume the recipients are no more advanced than us and use our present level of technology and scientific understanding as a baseline for detectability. In other words, if we can't detect it, neither can they. If that's the case, they would definitely struggle, if not be outright unable to detect some of the messages mentioned in this video. But should we really make that assumption? Well, to paraphrase Carl Sagan, any civilization even just slightly behind us wouldn't be able to receive or transmit, whereas any civilization on par with or billions of years ahead of us could be. Odds are they will be more advanced, making range and detectability estimates based on the assumption that they're not feel rather pointless. But it feels equally pointless to assume that they are more advanced, because then it just comes down to who writes the best science fiction. Does more advanced mean they have instruments that are similar to our own but simply larger and more sensitive? Does it mean they have long since abandoned radio technology in favor of something else entirely? Does it mean they have a more sophisticated understanding of physics and that their technology will appear to us as nothing short of magic?
I think it is a kind of intellectual chauvinism to assume that all the laws of physics have been discovered by the year of our meeting. Had we held this meeting 20 or 40 or 80 years ago, we would perhaps have erroneously drawn the same conclusion. We can only do our best with what we have, at whatever point in our technological evolution we are. But there will always be the possibility of yet undiscovered laws of physics. I think it would be a mistake not to bear this possibility in mind.
Habitability estimates suffer from a similar problem because we obviously don't know if what we regard as habitable is the same as what they regard as habitable. Even if we assume that intelligent life can exclusively emerge on Earth-like planets orbiting Sun-like stars, that does not mean they will stay there. Perhaps there comes a time in the lifespan of any civilization when their energy requirements outpace that which can be provided by Sun-like stars. Perhaps life is destined to seek out more extreme environments that we would never even think of as being habitable today. Perhaps the messages we've sent towards places most unlike our own are the most likely to receive a response. All this ambiguity is of course a big reason why many are so opposed to METI, because the unknown allows us to imagine the worst. For instance, in early 2010, Stephen Hawking cautioned against deliberate communication attempts out of concern that aliens might not be too dissimilar from our past and present selves.
We only have to look at ourselves to see how intelligent life might develop into something we wouldn't want to meet. If aliens ever visit us, I think the outcome would be much as when Christopher Columbus first landed in America, which didn't turn out very well for the Native Americans.
As we've already seen throughout this video, this pessimistic view on humanity and first contact is very common, and for good reason. There are plenty of examples throughout human history in which a less developed society suffered at the hands of a more advanced one. The problem with pessimism, though, is that it's one-sided. It would be just as easy to leverage more positive trends and behaviors in support of an optimistic outcome. For instance, consider this critique by philosopher 𝐂𝐤𝐿.
Are we to suppose that an intelligent life form vastly superior to us in scientific understanding and technological capacity would still follow simple goals not much different from those of the conquistadors? To answer yes is to take a deeply pessimistic view, not only of possible alien life, but also of human morality. It is to predict that humans would not be significantly better in 100 or even 500 years, even if scientific and technological progress continues unabated.
Considering how much we've improved in a very short span of time, things like child mortality, homicides, and poverty are declining, while access to clean water, electricity, and life expectancy are increasing, we only have to look at ourselves to see how intelligent life might develop into something we would want to meet. Perhaps not humanity of today, since, there's still plenty of room for improvement, but if we project these positive trend lines sufficiently far into the future, it's possible that much older civilizations will have long since outgrown their more destructive tendencies.
I don't believe aliens will pose a threat. I think that hostile tribes bent on war, be they terrestrial or extraterrestrial, destroy themselves with their own weapons long before they have any notion of how to attempt interstellar travel. Now, the more peaceful nations who study science and have perhaps cracked the secret to immortality are more likely to be benevolent, shy, and wary of contact for their own good reasons.
Just as Hawking justified his belief that aliens will be hostile by saying, "Look at all the bad things we've done," Frank Drake justified his belief that aliens will be friendly by saying, "Look at our capacity for growth." Neither argument is more or less valid than the other because we're obviously capable of both. But as the anti-METI crowd will often point out, this uncertainty is the problem. They will often argue that the mere possibility of an existential threat outweighs any potential benefits. To reiterate a quote from much earlier in the video,
"You see, it's not that I'm paranoid. I feel that there will be many civilizations that want to be our friends. However, it only takes one with a contrary point of view to ruin our day, our existence. Before people start sending signals into space on my behalf, I'd like them to ask for my permission."
A common counter-argument among those in favor of METI is that it's too late to worry about hostile aliens because we've been leaking radio signals into space for the better part of a century. Anyone within about 100 light-years of Earth could, in theory, detect our presence by intercepting our television broadcasts. But as opponents of METI are often quick to point out, this unintentional leakage is extremely faint and diffused. While it's impossible to say what signals are too faint for an alien civilization to detect, a weaker signal is obviously more difficult to detect than a stronger one. But it's not just about signal strength, it's also about intent. An archer blindly shooting arrows in random directions is a lot less likely to strike a bullseye than the archer aiming for the target. Sure, radio leakage could accidentally expose our presence, but METI goes out of its way to maximize that outcome. It's the difference between a ship lost at sea that happens to spot the faint glow of a coastal town and a lighthouse. There isn't much we can do about the former because it's merely a byproduct of our civilization, but there's plenty we could do about the latter, like, not build a lighthouse. While some critics advocate for precisely that, a planet-wide ban on METI, such proposals are often countered by what's known as the SETI paradox. It goes something like this: if we conclude that METI is too risky, and other civilizations reach that same conclusion, what would be the point of SETI if no one is transmitting? To quote the man who coined the term, the SETI paradox leads us to an inevitable conclusion. Either we do both METI and SETI, or we do nothing. The obvious problem with this argument is the assumption that all civilizations independently and inevitably reach the same conclusion. Even if we decided to cease transmitting tomorrow, that does not mean all other civilizations must behave as we do. In fact, this argument doesn't work even if METI is universally rejected, because an absence of deliberate emissions does not preclude the detection of unintentional ones, even if it is a lot less likely. So the SETI paradox isn't much of a paradox at all. It makes perfect sense to keep listening, even if we never send another message. But this is just a hypothetical, of course, because we probably will send more messages in the future. After all, a planet-wide ban would be extremely difficult to enforce, which is why some critics seek not to keep quiet, but to regulate the noise. While there's no consensus on what form such regulation should take, popular ideas include an international treaty or policy that places restrictions on METI, some sort of review board or oversight committee elected to make decisions on humanity's behalf, or a democratic process where, presumably, everyone in the world gets a vote, and the logistics of which I don't even dare to think about. While different policies and regulations could go a long way to reduce the number of transmissions, they're unlikely to eliminate the practice entirely. If people want to do something badly enough, there will always be a way to do it. Outlaw METI in one country and people will go to another. Make it illegal around the world and people will do it in secret. Hell, I wouldn't be surprised if a few messages have been dispatched in secret already. Think about it. Radio telescopes have been around for well over half a century. You're telling me not a single person has had the means and motive to beam a quick text to Proxima Centauri when no one else was looking. I'm not saying it's common, of course, but not once? I don't know about that.
The first members of our species to leave Africa about 100,000 years ago did not fear the unknown sufficiently to deter their travels, and European explorers of the 15th century sailed off into the unknown with death or discovery being about equally likely. Many died, but some discovered new continents. We are a curiosity-driven species. Science is a curiosity-driven venture. We will never stop being curious and seeking new knowledge unless or until it kills us.
As pointed out by evolutionary biologist Wallace Arthur, we are, for better or worse, a species that cannot stand not knowing. Whether it's the other side of a mountain, the other side of an ocean, or the other side of the galaxy, the unknown will always evoke fear in some and irresistible curiosity in others. No amount of debating is going to change that. Now, fortunately for those of you in Camp Fear, METI is extraordinarily unlikely to succeed. The stars we've targeted so far only account for a tiny fraction of the hundreds of billions of stars in the galaxy, most of which are within just a few tens of light years of Earth, even though the galaxy is about 100,000 light years across. For one of our messages to be received, the Milky Way is either so jam-packed with communicative civilizations that it's basically impossible to miss, or we would need to be luckier than the combined luck of all humans who have ever lucked, and then some. It's still fun to think about, of course, in the same way it's fun to think about other improbabilities like winning the lottery. It could happen, but it's probably not going to. So, in my view, it doesn't really matter either way, but if I had to pick a side, I think I'm more persuaded by the arguments against METI than those in favor. As much as I would like to have confirmation that we're not alone, tying one end of a rope around your waist and the other end around humanity before sprinting headfirst into a dark room, hoping there isn't a hole in the floor, is probably not the wisest approach. Thank you for watching.